Welcome to the Explainer. Today, we're going on a bit of an adventure. We are going to follow the journey of one single ray of light as it bounces and bends, and in the end, shows us how we see and how we shape the world all around us. Okay, let's just jump right in. We have all done this, right? You pick up a shiny spoon, you look into the inside curve, and there you are, a weird, tiny, upside-down version of yourself. Then you flip it over and bam! Suddenly you're all stretched out and wide. So what on earth is going on there? Well, to solve that little mystery, we have to meet the hero of our story. You see, it all starts right here, with just a single ray of light. And for what we're doing today, just think of it as a tiny, super fast traveler that always, and I mean always, moves in a perfectly straight line. This one simple fact is the foundation for, well, everything we see. But things start to get really interesting when our little ray of light hits something it can't go through. And that brings us to the first part of its journey, the bounce. This is what happens when our light ray smacks into a surface like a mirror. It can't pass through, so it's got to go somewhere. It has to bounce. Now, the scientific name for this is reflection, and it follows this one simple, really elegant rule. The angle that light hits a surface is the exact same angle that it leaves. Imagine a billiard ball hitting the cushion of a pool table. It bounces off at the exact same angle it came in at. Light does the exact same thing. This simple bounce is the first tool we have to control light. And this brings us right back to our spoon. If the shiny surface curves inwards, like the part you scoop soup with, we call that a concave mirror. If it curves outwards, like the back of the spoon, that's a convex mirror. Just two simple curves that create completely different ways of seeing the world.
So why would you curve a mirror inwards? Well, a concave mirror is a master of focus. It takes all these parallel rays of light and gathers them all together at a single point. This is why it's perfect as a shaving or a makeup mirror. It can create a bigger, magnified image of your face. It's also the secret behind a car's headlights, right? It concentrates all that light into a powerful, focused beam.
Okay, so what happens when you curve the mirror the other way? Well, a convex mirror does the exact opposite. It takes light rays and it spreads them out. And the result of that? A much, much wider field of view. This is exactly why they are so essential for safety, as rearview mirrors on our cars or as those big security mirrors you see in stores. They let you see a way bigger area than a flat mirror ever could. And here is where those concave mirrors get really interesting, and it's how we solve the spoon mystery. The image they make depends completely on how far away you are. So when you're far away from the spoon, the image is real and inverted, which is just a fancy way of saying it's upside down. But as you bring that spoon closer to your face, the image gets bigger and bigger until it suddenly flips and becomes virtual and erect, a magnified, right-side-up you that only looks like it's behind the spoon. It's a true shapeshifter. Convex mirrors, though. Oh, they're simple. They are predictable. They have one rule and they stick to it, no exceptions. No matter where the object is, the image you see will always be virtual, meaning it appears behind the mirror, erect, so it's right side up, and diminished, meaning it's smaller. That's why the objects in your passenger side mirror are closer than they appear. Now, you might think all this flipping and shrinking is just magic, but it's pure physics, and it's all described by this one elegant equation. This is the mirror formula. Now, don't worry about solving it. Just appreciate that this is like the code that perfectly predicts exactly where an image will form based on how far away the object is and the mirror's curve. It's basically the blueprint for reflection. Okay, so our light ray has bounced, but what happens when it hits something it can actually travel through, like water or a piece of glass? Well, that brings us to the second part of our little ray's journey, the bend. This bending is called refraction, and it happens because light literally changes speed when it moves from one substance, or medium, into another. The best way to picture this is with a shopping cart. Seriously. Imagine you're pushing it across smooth pavement, and one of the front wheels suddenly hits a patch of grass. That wheel slows down instantly, right? And that causes the whole cart to turn. Light does the exact same thing. And this is the second fundamental tool in our light manipulation kit. And we can harness this bending with tools we call lenses. A convex lens is thicker in the middle,
and it converges light, bending those parallel rays inward to a single point, like a magnifying glass. A concave lens, on the other hand, is thinner in the middle, and it does the opposite. It diverges light, spreading all those rays outward. Now hang on, does this sound familiar? A concave lens always gives you a virtual, upright, and smaller image. And what's so fascinating here is that its effect is almost identical to a convex mirror. One tool bounces light to spread it out, the other one bends light to do the exact same thing. Two totally different methods, but a very similar result. And this brings us to a really powerful idea. Okay, we've looked at bouncing light with mirrors and bending light with lenses. They seem like completely different things, but really, they're just two different tools for achieving the exact same goal. Let's just think of this as our light manipulation toolkit. Our one and only goal is to control the path of light. And to do that, we have two main tools. Tool number one, the mirror. Its method is bouncing. Tool number two, the lens. Its method is bending. And by simply shaping them, curving them inward or outward, making them concave or convex, we can make either of these tools focus light together or spread it apart. So why does understanding this toolkit even matter? Well, because mastering these two simple principles, bouncing and bending, has fundamentally changed how we see and interact with our entire universe. I mean, this isn't just theory in a textbook. This stuff is all around you. Your eyeglasses are just precisely shaped lenses that bend light to help you see clearly. Your car headlights are concave mirrors that bounce light into that strong beam. And our trusted rearview mirrors are convex mirrors, bouncing light to give us that wide, safe view. Telescopes, cameras, microscopes, they're all just brilliant, complex combinations of these two fundamental tools working together. So we followed our ray of light, and we've seen how its simple journey can be manipulated to create everything from a weird reflection in a spoon to images of galaxies far, far away. But our source material leaves us with this one final, kind of mind-bending thought. A modern quantum theory of light emerged in which light is neither a wave nor a particle. What that really tells us is that our simple little traveler, well, it isn't so simple after all. Its true nature is far stranger and more mysterious than we can imagine, which just leaves us with one final question to think about. What do you think light really is?